Two-variable inequalities. In this video, you'll learn that when given a two-variable inequality and the graph of a related equation, how to determine which side of the line the solutions to the inequality will fall. You'll also learn how to describe the graph that represents the solutions to a linear inequality. Let's start by looking at equations versus inequalities. A linear equation in two variables has specific solutions that form a line on a graph. And a linear inequality in two variables has many solutions that form a shaded region on the graph. So if we have the equation y equals 2x plus 1, we'll have a graph of a line that shows all solutions to this equation. If we have the inequality instead of y is less than or equal to 2x plus 1, we'll have a shaded region of the graph showing us all possible solutions to this inequality. Let's look at the boundary lines of an inequality. A boundary line separates solutions from non-solutions. So for symbols less than and greater than, the boundary line is not included, so we'll use a dashed line. And for symbols less than or equal to and greater than or equal to, the boundary line is included, so we'll use a solid line. So if we have y is less than 2x plus 1, then our line will be dotted since it doesn't include the line as solutions. But for y is less than or equal to 2x plus 1, this one will have a solid line because the line under the symbol tells us that it can equal that line as well. Now let's look at the solution ranges. We will shade the solutions to the inequality based on the symbol they use. So for symbols greater than or equal to, we will shade above the y-intercept. And for symbols less than or equal to, we will shade below the y-intercept. So we have two inequalities that look identical, except for our symbols are greater than or equal to, and then less than or equal to. So both graphs will have a solid line, but for greater than or equal to, we'll shade above that y-intercept, and for less than or equal to, we'll shade below the y-intercept. So let's just recap what each symbol will represent on a graph. Less than will be a dotted line and will shade below the y-intercept. Greater than will also be a dotted line, but will shade above the y-intercept. For less than or equal to, we'll have a solid line and will shade below. And the greater than or equal to will also be a solid line, but will shade above the y-intercept. Let's determine if the graph of each linear inequality will have a solid or dashed line, and if it will be shaded above or below the y-intercept. We'll start with y is greater than 2x minus 1. The greater than symbol tells us the line will be dotted and will shade above the y-intercept. For y is less than or equal to negative 3x plus 4, the symbol tells us that we'll use a solid line because it has the equal sign under it, and we'll shade below it since we want values less than. On the next example, we need to first put this in slope-intercept form, because multiplying or dividing by a negative might change our symbol, so we just have to make sure it's in slope-intercept form before we analyze the symbol. So we'll start by subtracting 2x on each side. This gives us y is less than 5 minus 2x. Now we can look at the symbol. So if it's less than, our line will be dotted and will shade below the y-intercept. Now let's practice graphing these inequalities. We'll start with y is greater than 1x plus 2. We always start by plotting the y-intercept. In this inequality, our y-intercept is 2. So we'll put our first dot on the y-axis at 2. Then we're going to plot 3 more dots by using the slope. Our slope is positive 1. So we'll go up 1 over 1 and repeat this. So now we can see a line forming. Now we're going to draw the line. The inequality symbol used is greater than, so since it doesn't have the equal sign below it, our line will be dotted. Now let's shade the region. So with the symbol of greater than, we want all values greater than the y-intercept. So we'll shade above that line. Let's try another one. First, let's bring this inequality down so that we can get it in slope-intercept form. So we'll have to solve for y, and we'll start by subtracting 2x from each side. This will give us y is less than or equal to negative 2x minus 3. We'll put this up here for now so we can finish our steps. We'll start by plotting our y-intercept. In this example, our y-intercept is -3. So we'll put this on our y-axis at -3. Now we'll use the slope to find some more points. Our slope is -2, so we can go down 2 over 1, but since our graph cuts off pretty close to the end, we'll go up 2 and backwards 1 instead. So up 2, back 1, and we'll repeat this, and now we can see the line forming, so we'll draw the line. We see the symbol is less than or equal to, so the equal sign says that this line will be a solution. So we'll use a solid line. Now let's shade the region. For the symbol less than or equal to, we'll shade below the line. Here's one more. Y is greater than or equal to -2x plus 4. We'll start by plotting our y-intercept, which is 4. So we'll put this on our y-axis, and now we'll use our slope of -2 to form a couple more points. So we'll go down 2 over 1, and now we can see a line forming. The inequality symbol greater than or equal to tells us that our line will be solid. So we'll draw a solid line. And then the symbol greater than or equal to tells us that we'll shade above the line. So now we have our shaded region for all possible solutions. Let's recap what we've learned. While linear equations have a line that represents all possible solutions, a linear inequality has a range and a boundary line to represent possible solutions. The boundary line is solid if the inequality symbol is less than or equal to or greater than or equal to, and it will be a dashed line if the symbol is less than or greater than. This symbol will also tell us where to shade.